3I, Atlas synchronized to Earth's rotation, and that's just the beginning. 81 hours ago, astronomers confirmed what should have taken millions of years. 3I Atlas's rotation period matches Earth's sidereal day with precision that exceeds atomic clock accuracy. 23 hours, 56 minutes, 4.0916 seconds. Not 4.09 seconds, not 4.1 seconds, 4.0916 seconds. That's synchronization to the millisecond. And it happened in 6 hours through discrete adjustments that violated every principle of rotational physics we understand. That's not tidal locking, that's deliberate coordination. Tidal locking occurs when two bodies orbit closely for millions of years. Gravitational forces gradually synchronize rotation periods. The Moon is tidally locked to Earth after 4.5 billion years of interaction. 3I Atlas, synchronized in 6 hours from hundreds of thousands of kilometers away. The timescales are wrong by a factor of billions. The distances are wrong by orders of magnitude. This is not natural physics. This is active control. Before I show you the rotation data that 17 observatories confirmed independently, before I explain why synchronization at this distance and speed is impossible through any known mechanism, before I reveal what the synchronization pattern tells us about Atlas's targeting priorities, I need you to understand what millisecond precision means. Earth's rotation varies by milliseconds due to earthquakes, ocean currents, and atmospheric changes. We measure these variations with atomic clocks and adjust our timekeeping accordingly. Atlas matched Earth's rotation, including these variations. Real time, continuously. That's not matching a number. That's tracking a moving target. In the comments below, tell me this. When an object 400,000 kilometers away matches Earth's rotation to the millisecond, despite having no physical connection, what's the simpler explanation? Gravitational coupling that works a billion times faster than physics allows, or sensors measuring Earth's rotation and actuators adjusting to match, because one requires rewriting celestial mechanics, and the other requires accepting that Atlas has gyroscopes and control systems. Let me start with what Earth's sidereal day actually is and why it matters. Most people think Earth rotates once every 24 hours. That's the solar day, the time between successive noons. But Earth is also orbiting the sun day. By the time Earth completes one rotation relative to distant stars, it's moved slightly in its orbit. To bring the sun back to the same position in the sky requires an additional 4 minutes of rotation. The sidereal day is Earth's rotation period relative to the stars, 23 hours, 56 minutes, 4.0916 seconds. This is the period that matters for astronomy, satellite operations, and celestial navigation. It's not a round number. It's not convenient. It's the actual physical rotation period of our planet. Now, here's why Atlas matching this specific number is significant. If Atlas just wanted to rotate at roughly 24 hours, it could have chosen any period between 23 and 25 hours. But it chose 23.9344 hours exactly. That's not rounding, that's targeting the precise value. The only reason to match Earth's sidereal day specifically is if you're maintaining orientation relative to Earth's surface and the celestial sphere simultaneously. Let me walk you through the synchronization event because the timeline reveals intent. Before synchronization, Atlas rotated with a period of 27.3 hours. This period was stable for 2 weeks. Brightness variations showed consistent 27-3-hour cycles. The rotation axis was oriented roughly perpendicular to Earth's orbital plane, but the period was unrelated to Earth's rotation. On January 28 at 14:22 UTC, the rotation period began changing, not smoothly. In steps, the first measurement after change showed 24.1 hours. The rotation had suddenly accelerated. 90 minutes later, the period was 23.95 hours. 2 hours after that, 23.93 hours. By 2:15 UTC on January 29th, it had stabilized at 23.9344 hours. 4 discrete steps. Each step brought the period closer to Earth's sidereal day. Each step was separated by time intervals, allowing the new rotation rate to stabilize before the next adjustment. This is control system behavior. Measure current state. Calculate error from target. Apply correction. Measure again. Iterate until target achieved. The final period of 23.9344 hours equals 86,164.0 seconds. Earth's sidereal day is 86,164.0916 seconds. The difference is 0.0916 seconds, which is within our measurement uncertainty given the observational cadence of brightness variations every few minutes. We cannot measure more precisely than that with current techniques. But within our ability to measure, Atlas matched Earth's sidereal day perfectly. Now, let me address why this precision eliminates natural explanations. Tidal locking is the only known natural mechanism for synchronizing rotation periods between celestial bodies. It occurs when gravitational gradients across an object create torques that gradually slow or speed rotation until it matches the orbital period. The Moon is tidally locked to Earth. The same face always points toward us. This happened because Earth's gravity is strong enough to create measurable tidal bulges in the Moon's structure. Over billions of years, friction from these bulges dissipated rotational energy until the Moon's rotation synchronized with its orbital period of 27.3 days. But tidal locking has requirements. First, the two bodies must be close. The tidal force drops with the cube of distance. Double the distance, tidal force drops by a factor of 8. The Moon orbits at 384,000 kilometers. Tidal forces are just barely strong enough to maintain lock. Atlas orbits in a Molniya orbit that ranges from 200,000 to over 600,000 kilometers. At those distances, tidal forces from Earth are negligible. Second, tidal locking synchronizes rotation period with orbital period, not with the planet's rotation period. The Moon's rotation period of 27.3 days matches its orbital period of 27.3 days. That's what tidal locking does. Atlas's orbital period is approximately 12 hours in the Molniya orbit, but it's synchronized to 23.93 hours, which is Earth's rotation period. That's not tidal locking, that's something else. Third, tidal locking takes millions to billions of years. It's a slow accumulation of tiny torques over geological timescales. Atlas synchronized in 6 hours. That's 13 orders of magnitude faster. You cannot speed up tidal locking by any mechanism known to physics. The energy dissipation rate is fixed by material properties and tidal force strength. Every aspect of the synchronization contradicts tidal locking. Wrong distance, wrong target period, wrong time scale. Tidal locking cannot explain this. We need a different mechanism. Let me walk you through what millisecond precision requires. Earth's rotation is not constant. It varies by milliseconds day to day due to atmospheric angular momentum changes. It varies seasonally due to ice and snow redistribution. It varies from earthquakes redistributing mass. We track these variations with International Atomic Time and adjust coordinated universal time accordingly. For Atlas to maintain synchronization at millisecond precision, it must track these variations. It must measure Earth's actual rotation continuously and adjust its own rotation to match. This requires sensors, gyroscopes to measure Atlas's rotation, star trackers or Earth sensors to measure Earth's rotation, and actuators capable of making fine adjustments to maintain lock. This is precision attitude control. Spacecraft use reaction wheels, control moment gyroscopes, and thrusters to maintain specific orientations. The International Space Station maintains pointing accuracy of 0.5 degrees using these systems. Atlas is maintaining rotational phase lock accurate to milliseconds, which is far more precise than ISS attitude control. The control system must also be autonomous. There's no real-time communication with controllers. The round-trip light time to HD 3651 is 72 years. Even if controllers exist there, they cannot send corrections fast enough. Atlas's control system operates independently, making decisions and adjustments without external input. Now, let me address what synchronization enables. When an object's rotation period matches Earth's sidereal day, it maintains constant orientation relative to Earth's surface. If Atlas has sensors on one face pointing toward Earth, those sensors remain pointed at the same geographic locations as Atlas orbits. This is geostationary satellite logic applied to a non-geostationary orbit. True geostationary satellites orbit at 35,786 kilometers altitude, moving at exactly the rate Earth rotates, hovering over one spot. But geostationary orbit only works at the equator and at that specific altitude. Atlas can't be geostationary because it's not at the right altitude. But by synchronizing rotation with Earth's day, Atlas achieves a similar effect. As it moves through its Molniya orbit, it rotates at exactly the rate that keeps the same face pointed toward Earth's surface. If instruments are mounted on that face, they maintain consistent ground coverage despite the orbital motion. The Molniya orbit is optimized for Northern Hemisphere observation. The apogee, the highest point, occurs over the Northern Hemisphere. Atlas spends most of its 1-2-hour orbital period near apogee, loitering over high latitudes. Combined with rotation synchronization, this creates a platform capable of extended observation of specific ground locations. This is surveillance satellite architecture. This is what we do when we want persistent monitoring of specific regions. The combination of orbital geometry and rotation synchronization isn't coincidence. It's deliberate mission design for observational objectives. Let me walk you through what the synchronization axis tells us. Not only does Atlas rotate at Earth's rate, but its rotation axis is oriented to maximize Earth observation. The axis is tilted approximately 23.5 degrees to Earth's orbital plane, roughly matching Earth's axial tilt. This means Atlas's equator aligns with Earth's equatorial plane. If Atlas has a belt of sensors around its equator, aligned with its rotation axis tilted to match Earth's, those sensors would sweep across the full range of Earth's latitudes as Atlas orbits. Combined with the rotation keeping the same face toward Earth, this provides complete coverage of Earth's surface over multiple orbits. The geometry is optimized, not random, not coincidental. Deliberate configuration for maximum observational efficiency. Every aspect of Atlas's orbital mechanics and rotation dynamics points toward designed observation platform executing reconnaissance mission. Now let me discuss what happened to the deployed secondaries when Atlas synchronized. The 6 objects in hexagonal formation maintained their positions relative to Atlas through the rotation change. As Atlas's rotation period decreased from 27.3 to 23.93 hours, the secondaries adjusted their formation geometry to maintain the 2,847 kilometer spacing. This coordination between Atlas and the secondaries during rotation reconfiguration demonstrates fleet-level control, Atlas synchronized to Earth, the secondaries synchronized to Atlas. All 7 objects maintain precise spatial relationships through dynamic reconfiguration. This is distributed autonomous coordination, each unit aware of the others, each adjusting to maintain formation despite changing conditions. The synchronization also affected the radio signal. The 1,420 MHz emission pattern changed when rotation synchronized. Previously, signal strength varied with rotation as different parts of Atlas pointed toward Earth. After synchronization, signal strength became more constant. This suggests the transmitter is now maintaining fixed orientation toward Earth, enabled by the rotation lock. Let me address the energy requirements for synchronization because they're substantial. Changing rotation period from 27.3 hours to 23.93 hours for a 47 million ton object requires enormous energy. I calculated this in the spin-up analysis, approximately 30 terajoules to change rotation rate. But maintaining synchronization also requires energy. Small perturbations from solar radiation pressure, outgassing, and gravitational interactions constantly nudge Atlas's rotation. To maintain millisecond precision lock requires continuous small corrections. These corrections require torque, which requires energy. For a 4-7 million ton object, maintaining millisecond precision attitude control, estimated power consumption is approximately 5 megawatts continuous. That's 120 megawatt hours per day. Over 3 months, that's 10,800 megawatt hours just for rotation control. This is in addition to the 1.4 gigawatts consumed by other systems. The energy to maintain synchronization must come from the onboard reactor. Solar power is insufficient. The 5 megawatt requirement for rotation control alone exceeds the 9 megawatt net solar power available. Add this to thermal management, communications, station keeping, and internal systems, and you absolutely need the gigawatt-scale reactor we calculated in the energy budget analysis. Now let me discuss what synchronization tells us about mission priorities. Atlas could have maintained any rotation rate. It could have tumbled chaotically like natural asteroids. It could have chosen a rapid spin for stability. It could have chosen slow rotation to minimize stresses. Instead, it chose the one rotation rate that maintains fixed orientation relative to Earth. This choice reveals priority. Earth observation is important enough to justify the energy expenditure of precise rotation control. Important enough to maintain millisecond accuracy continuously. Important enough to remain the primary configuration even as other mission phases proceed. The synchronization occurred after orbital insertion but before secondary deployment. This timing suggests mission sequence. First, establish orbit. Second, configure for observation. Third, deploy subsystems. The rotation synchronization was phase 2. Everything since has been conducted from this observational configuration. Let me walk you through what we can infer about what Atlas is observing. The Molniya orbit's apogee occurs over the northern hemisphere, roughly over northern latitudes 60 to 70 degrees. Atlas spends 8 hours of its 1-2 hour orbit above 5 degree latitude. During this time, with rotation synchronized to Earth, instruments can continuously observe northern regions. What's at those latitudes? North America, Europe, Russia, most major population centers in the northern hemisphere, most military installations, most space launch facilities. If you wanted to observe human civilization's technological infrastructure, you'd focus on northern mid-latitudes. That's where most activity occurs. The synchronization enables time series observation. By maintaining the same orientation over multiple orbits, Atlas can track changes, monitor construction, watch movement, detect patterns. This is reconnaissance tradecraft, establishing baseline, tracking deviations, building comprehensive intelligence picture. Now, let me address the institutional response, because it's been revealing. When rotation synchronization was first confirmed, NASA issued a statement calling it unusual rotational behavior likely due to complex outgassing dynamics. This is absurd. Outgassing produces chaotic torques. It doesn't create millisecond precision synchronization to Earth's sidereal day. The European Space Agency initially acknowledged the synchronization, but suggested it might be coincidental resonance. Coincidental resonance would be if the periods were approximately similar. They're not approximately similar, they're identical within measurement precision, and they became identical through a series of controlled adjustments. That's not coincidence or resonance, that's control. After these initial inadequate explanations, official statements stopped. Now there's just silence. No press releases, no papers explaining the synchronization, no attempt to provide natural mechanism. The silence suggests institutions know natural explanations don't work and prefer no explanation to acknowledging artificial control. I've communicated with colleagues at space agencies globally. They acknowledge privately that synchronization cannot be explained through known natural processes. They've run simulations. They've consulted experts. No natural mechanism produces this behavior, but publicly, they say nothing. Career preservation trumps truth. Now let me make predictions based on synchronization. First, the rotation lock should remain stable indefinitely unless Atlas chooses to change it. Natural perturbations are too weak to break the lock if active control maintains it. If lock breaks or changes, it will be deliberate reconfiguration for new mission phase. Second, we might detect the control systems maintaining lock, gyroscopes, momentum wheels, thrusters, small adjustments producing small signatures. If we monitor closely enough with sensitive instruments, we might see evidence of active attitude control. Third, the rotation axis might slowly precess if Atlas is tracking Earth's axial precession. Earth's axis precesses with a 26,000-year period. Over months or years, we might see Atlas's axis adjusting to maintain alignment with Earth's. This would further confirm deliberate tracking. Fourth, if mission priorities change, rotation configuration might change. Different observation targets might require different geometry. Synchronization might shift to different period or different axis orientation. Any change would be deliberate and would reveal new mission objectives. Let me address what synchronization means for threat assessment. An object maintaining fixed orientation relative to Earth's surface is optimized for targeting. If Atlas has capabilities beyond observation, those capabilities are now continuously aimed at specific geographic regions. Whether kinetic weapons, directed energy, or something else, the platform is configured for engagement. We have no evidence of hostile intent, but capability exists. A spacecraft maintaining firing solution geometry continuously is a strategic asset or liability depending on whose control it's under. Atlas is under someone else's control. Someone 47 light-years away who sent it here 500 years ago and programmed it with objectives we don't understand. This is why transparent monitoring and international cooperation are essential. We need all nations tracking Atlas continuously. We need shared data on any changes. We need coordinated response protocols. An object in optimized strike geometry that we don't control is everyone's concern, not one nation's problem. The synchronization is documented. 17 independent observatories confirmed it. 23 hours, 56 minutes, 4.0916 seconds. Matching Earth's sidereal day to millisecond precision. Achieved in 6 hours through controlled adjustments. Maintained continuously for months with no degradation. Natural processes cannot do this. Tidal locking doesn't work at these distances, timescales, or target periods. We're left with active control. Sensors measuring Earth's rotation. Actuators adjusting Atlas's rotation. Control systems maintaining lock with precision exceeding our best spacecraft. Demand that institutions acknowledge what millisecond synchronization means. Demand transparency about the mechanism. Demand honest assessment of what synchronized rotation enables. Atlas is configured for Earth observation, optimized for persistent monitoring, maintaining orientation that maximizes coverage of human civilization. The synchronization isn't anomaly, it's mission configuration, and that mission is pointed at us. Stay rational, stay vigilant, and remember that when something synchronizes to your planet's rotation with atomic clock precision, it's not watching the scenery, it's watching you.